Good day, ladies and gentlemen. Welcome to today's weekly live session. Today, we'll talk about surface mining and opportunities on how you can use Digital Africa to have an overview of mining activities and the impact on the land. Digital Africa is powered by partnership, started 4 years ago, and has been working with different partners across the continent to empower countries on how to access analysis ready data to empower the greater natural resource management. Digital Africa uses the Open Data Cube technology and powered by Amazon Web Services. Digital Africa is working with partners across the continent who've been very instrumental in providing guidance on some of the continental services, as well as the notebooks and the various use cases Digital Africa has been able to work. We continue engaging with different countries so that we leave no one behind. In today's session, Digital Africa will demonstrate methods of how you can identify some of the surface mining activities. The workflow includes assessment on vegetation loss and looking at change in water. Here we're able to detect areas also when we have validation in terms of ground data. We can be able to see where mining activities have been and how the government is working to regulate some of the sectors and the impact of such mining activities on the land in terms of land degradation. Surface mining itself refers to the actual abstraction of resources where most of our mines are under the surface. And these will include retrieving sand, gravels, and other metals. This is quite involves a lot of cost when some of the tunnels are dug and shafts to access these mineral resources. South Africa now actually will demonstrate how to look at assessment of vegetation loss. Here, Digital Africa uses the Sentinel-2 optical cloud-free mosaics called GeoMat. Also, additionally, Digital Africa is able to provide the Sentinel-1 analysis radar format. And for the detection of water, Digital Africa has the water observation from space, which has been developed using Landsat data, covering over 38 years of data, quite impactful. So most of the mining activities would include clearing of vegetation and also at sometimes abstraction of water from the land. Some of the tools used, the Sentinel-2 at 10 meters are quite useful because they give you that information at 10 meters you can see from above, and the various indices we can see the vegetation loss. Then with the Sentinel-1, which is able to ride that cloud-free, it's able to go through, see through the clouds, adds that value of providing those assessments from space. And the water observation from space gives that aspect of what has happened the last 38 years or so. And that workflow, we start first by a chosen area where it is area where you've observed some of the activities. Also a given time period, because then we'll see the times to our mining activities and when these activities ended, what was the impact on the land, or the activities might have reemerged later on. Then when we look at the change in vegetation, we are using the normalized difference vegetation index for the Sentinel-2 and the radar vegetation index for Sentinel-1. Then for the presence of water, we have the water observation from space. And then we're able to combine these two, change in vegetation and water extent, to actually show possible mining areas and the resulting effect on the vegetation. So as you can see in this particular workflow, it's an example of a Parama forest in Ghana near Ofin River, as was shared earlier on with the Ghana Statistical Service, working closely with the Environmental Protection Agency. This was one of the earlier use cases Africa was able to work together, different partners, different sectors. So looking at the area itself, where even some journalists were taken around Obuasi, the change in vegetation around the years of 2017, 2018, 2019, 2020. Then looking at the presence of water, where it was said some of the water was used to maybe transport some of the mines. And looking at the impact of the vegetation, it was quite high, but things have improved later on. So The workflow, as we described step by step in your sandbox, we have the surface mining tool, allows you to load the data and also the extent of the area. In this particular case, we're able to add a shapefile of a permafrost. Then we have the start of the year and the end of the year and Sentinel-2, and looking at the areas, calculating the vegetation and also the extent of the water and plotting the areas of possible mining or areas also vegetation loss. So the particular workflow as shown, we've loaded the area of interest, and also we are checking for the change in vegetation over the different years. And we could see some peak areas around this particular time between the years 2018 2019. And somehow there was some regulation, and later the activities might have resumed. And the results we are getting from the tool shows that from the 2 3 years, we're able to see areas of possible mining, which some of them are around Ofin River, and some of the mining areas are just areas which could have been concessioned as mining, or later, due to exposure and land degradation, appear to be open pits, which will require possible interventions, for example, replanting of trees and other reforestation activities, which are key to helping our countries cope with the impacts of climate change. For the impact and loss of the vegetation, we're able to see where we were able to report the loss in vegetation. We could see also rising vegetation loss from possible mining activities. And then we had ways of mitigating this. First of all, stopping the mining activities and also closely working with the communities to sensitize these areas, how they could be preserved, and the planting of trees. As we saw the workflow, the area was selected, and we've seen the change in vegetation. We also able to see the presence of water, especially around Ofin River. And also, as a result, we're able to see the change in vegetation between those 3 years, and having the most extent around 2020, where quite activities were ongoing. But later on, there were some interventions to stop some of the activities and provide possible alternatives to the different livelihoods which were affected. So the notebook in your use cases folder, surface mining. When you go to the surface mining, you're able to look at the few steps involved and the scripts in the background, helping us to go through importing of shapefile or KML, loading the GeoMat Sentinel-2 at 10 meters, and also loading the water observation from space, and giving us the change in vegetation, vegetation index, and also showing us possible areas which have been affected by the loss in vegetation, and possibly when these activities were, different years, and also possibly where some interventions have been made to stop some activities and possibly see how to restore the landscapes. So looking at the 2 years, the year of 2017 as a start and the end of 2020, loading the shapefile and threshold, are we able to capture the extent of the forest? You'll see Ofin River somewhere, and then we able to see the Sentinel-2 on the water observation from space and the change in vegetation as was highlighted earlier on. And the water observation from space, we will see possible mining areas, but then also we can compare to get for each of the years. So we're able to see the year and the month and possible hotspot areas and possible interventions. It's a very useful tool, as you've seen, and also even printing such a map to discuss with the relevant authorities and agencies and even the communities to sensitize on the how to work. We're able to also change some of the dates, for example, from 2017 to 2022. just to see how the situation would have been as moving from the earlier use case. And then we had further developments, addition of the Sentinel GeoMod up to 2020, and there are plans to add it in 2023. This is quite a useful tool, and when as we're able to load some of the data sets, we could see a similar change, quite highlights in 2022, 2021, but later on things changed a little bit. And as you can see there, the scenario, and there were quite some policies put in by the Environmental Protection Agency, as well as sensitization of various communities, and at least a good, we could say a little bit, things look a little bit more improved. I'm also looking at how to look at it in the Digital Africa map, because we've had the questions of how you can do the comparison. Looking at a Parama forest, loading in the data, you could go to the continental data sets and look at the geomads. You can put in the Sentinel-2 imagery just to see how the area looks. And this is at 10 meters. And we could change the different dates. And looking at the earlier use case, also you can access the same service and get its metadata information. Very key information, that is documentation. And when we do the comparison, we're able to start with the year 2017 and just see the situation on the left. The other one is on the right is 2024. We can also change to 2020, which was the ideally when we were comparing the use case around Ofin River. We could see quite some changes and also growth of some of the areas. On the right is in the recent one. Also, we could change the different band combinations on the fly. This is the vegetation index, just to see the situation, especially when we have the rivers, quite some degradation around some hotspot areas. And also we could add in the water observation from space, just to have a feel of what we had in the sandbox and have it on the Digital Africa map. Yeah, we are also able to load the water observation from space and also change the legend from blue, constantly blue, and red, possibly areas which have had water at some point but have dried, possibly areas where they could have some usage and then the water dried at certain times. And also cognizant of our rainy seasons around August, July. We're able to change different bands on the fly just to get that particular combination, which gives us an aspect of change in vegetation. But the muds look fairly okay. And if we're able to change that, this other option, you'll see quite something is happening on the right image. And also we have the MUDS CEMAT, which is it's like a principal component analysis, giving you the dimensions of different bands, and also very useful to provide what is happening in the landscape. The 2020 image looks quite a lot of land degradation was observed, and you can do a comparison. And also we could also see, why not check an imagery of a recent Sentinel-2, which is analysis ready format. We could filter by location, look at an imagery right now in April, quite cloudy, but you can move to earlier the year where we possibly hoping for cloud-free in early Januaries. And that is the case. You could see quite degraded landscape, and you can do a comparison to see how it was in 2017 January, around the same year. We could actually see quite some change when you filter by location for that particular imagery, so that it can load a Sentinel-2 imagery. So you can be able to see quite interesting results. Then we are changing to get a cloud-free in early January. And you can see the area actually has really changed over time. coupled with land degradation from the mining activities, also possibly the drying of the region over time. This has been quite some of the factors observed. And moving to a different year, you could see the scenario and looking for cloud-free uh, imagery, seeing the degradation went through 2017, 2018. And you can share this link with someone, and very useful to share results and also key messages to work on the ground validation data with the different communities and different partners. We wish to share another example of mining in Madagascar, which was shared with one of our colleagues, just looking at two sites, Rio Tinto and Batovi in Madagascar. And these areas were observed to have quite some activities happening. And the areas also, the possible areas of mining you can see over time, and also some water ponds for some cleaning of the minerals or for mineral processing were observed. And when we look at also change in vegetation, it was quite consistent with the actual loss the vegetation in the region, and some of it attributed to mining activities observed. And generally, the region also was drying over time. Also looking for the other example of Abatovi, similar mining activities and the loss in vegetation attributed to mining as well was also observed. But the other example was quite Rio Tinto had more impact, or there were more activities, and the impact on the land was quite high. So just trying to give you a demo on this particular notebook. We worked to get a shapefile of the area. And when you load, you can copy the shapefile of KML into that particular location. And when you run it, you can see the region, how it was really affected, the annual itself of vegetation, but also identifying some of the potential mining areas in the region, and also looking at how it compares with the actual loss in vegetation on these particular areas, and also to be able to capture several years and how this was impacting mining activities. Also, sharing another example is how about we look at the region itself in the Digital Africa map. So going to a part of the example, Rio Tinto example, we're able to load in the geomats, and we're able to get the image as of 2024, and then we compare on what was earlier in 2017. And we can see general change of vegetation in the region over time. However, also we have dates that we could change. 2020, we could see the scenario, and we move between two dates. You can actually see on the right side the 2020 image, quite a lot of degradation observed. And also we could add in some other data sets like in the water observation from space. The summary could give us an idea of some of those water ponds and wetlands around the area. And the ones green to red sometimes were water, sometimes were not water. The one in blue remained water, and also helps us to use the Digital Africa Water Bodies service to look at those small water bodies. We're able to click on them and see when were these water ponds had water. You can see the dates, possibly when they were dug. They remained dormant for a while and were just activated during certain times. And over time, they had dried. So it gives an opportunity to do comparison, and also an opportunity to use this example for other parts of the continent based on the ground information, just to have that ecosystem of supporting the various decision-making activities and empowering our government's regulation, and also educating our citizens on the regulated mining, and also uh, a good strategy, because we need the minerals also for sustainable development. So everything in moderation and how to balance these activities versus the livelihoods being supported. So Digital Africa provides online self-paced courses. We also have the introduction to the sandbox, the water resources, agriculture, as well as one of the courses in land regulation, which will give you an idea of some of the work being developed by our partners. Observations are held in Tunisia, where they're working on soil organic carbon and land degradation service for Burkina Faso and Tunisia. And that will also be available later on to see how it can support some of the work. And Digital Africa conducts these live sessions in English and French. Our session today has been in English, surface mining, and the next one next week will be in French, and the other week we'll have something on flood extent and so on. We continue to connect with you each week, and also Digital Africa is grateful for the partners, especially the Australian government, Hamzi Trust, and other partners who've supported the program as we continue to grow the ecosystem of stakeholders. And also very grateful for everyone who's been able to join and also who are watching the recording to actually connect with us. And also when you scan the QR code, we'll be able to connect with you so that we can share more information about the amazing work. This one is only possible with your support so that we can move further in having a peace and prosperous Africa. Thank you so much for joining us today. Thank you.